Okay, here's how to do the calculations for the percent mass of hypochlorite in bleach. First of all, I hope you balance the equations correctly. The equations are in your laboratory notebook, so if you don't have them balanced correctly, the stoichiometry is not going to turn out for you. But let's say, for example, that your titration used 20.00 milliliters of sodium thiosulfate. So, this is where you're going to start. You're going to start with that piece of given information. 0.02000 liters, right? And you're going to write Na2S2O3. That's over 1. You know the concentration of sodium thiosulfate was 0.1 molar. So 0.1 mole of Na2S2O3 to 1 liter. You also know that in the stoichiometry, if you look at the balanced chemical reaction, that 2 moles of sodium thiosulfate reacted with 1 mole of I3 1-. And I'm about to run off the page. So I'm going to stop this I'm going to stop this calculation here and write a number. So that number 0.02 times 0.1 divided by 2, 0.001. 0.001. And now what is the unit that's going to be there? The liters are gone, the moles are gone, and I'm at I3. So 0.00100 moles of I3 1-. And the next step is to look at the relationship between the I3 1- and the I2. That's a 3-to-3 relationship. So 3 moles of I3 1- to 1 to 3 moles of I2 1-. And then you recognize that in the very first step, wow, that looks not very neat. Okay, you had 1 mole of I2 produced when every 1 mole of hypochlorite was reduced rather, sorry. Okay, so that number turns out to be you'll see the math there, 0.00100 moles of NaClO. Okay? Now think this through. This is the number of moles of sodium hypochlorite that was in your aliquot. Okay? So that is how much you sucked up with your pipette, and you put that in the Erlenmeyer flask. So every single time you had that amount of sodium hypochlorite, that's how much you must have had in the Erlenmeyer flask. So now what you have to do is do a percent by mass. So in the percent by mass, you know that you need grams of sodium hypochlorite in the bleach solution. Okay? And this all has to be grams to grams. So basically we have to convert this to grams, and then we have to figure out how much bleach solution this was for that amount of moles of sodium hypochlorite. Here's the stoichiometry that I used to work this out. 0.001 moles of sodium hypochlorite in 1 aliquot. Okay, notice that's the piece that's on top. Okay, so this moles is going to eventually convert to that grams. I know that an aliquot, remember what the aliquot was? The aliquot was 20 milliliters of the diluted stuff. Okay? And 100 milliliters of the diluted stuff was made from 5 milliliters of the concentrate. Now look what I've done now. I have the concentrated or the bleach solution on the bottom, and that's exactly what I have to have. So here I'm going to have to convert this into grams. And so the concentrated bleach solution had a density of 1.08 grams per milliliter. So you can see that the 1.08 grams, so that's the density of the concentrated stuff. All right? So then I have effectively gotten to the concentrated, but I still haven't dealt with the moles of hypochlorite. So in order to deal with the moles of hypochlorite, I have to do what? Find the molar mass. So the molar mass of hypochlorite is 74.44 grams per mole. Okay? So you guys do the math. I'm sure that when you do the math, you're going to figure out that aliquot cancels, dilute cancels, concentrated cancels, and so you're left with grams of concentrate on the bottom and grams of sodium hypochlorite on the top. My number for this was, I forget what it was, 0.001 divide 20 times 100 divide 5 divide 1.08 times 74. So my number was, you can see the calculator screen, 0.069. 0.06, actually I'm going to go to 4 significant figures, 93%, or actually grams per gram. So multiply that by 100, I get 6.893%. So I think that I was looking at a couple lab groups. This is about what it was for the what we call the new bleach. So it was on the order of 7% bleach. See how that's done? I'll see you in class on Monday.